Hello, today we are going to install the application JetBrains Toolbox. From there we're going to install the integrated development environment for C++ IntelliJ JetBrains CLion. And then we're going to use this integrated development environment CLion for programming for KDE. We have instructions for these. So let's go to the wiki page, get involved, development. There's the button configure the integrated development environment, CLion. These are the instructions on how to install CLion, but we're going to install another application, and from there we're going to install CLion. Let's go at the end of the page. So there's the external link to my wiki page. Let's keep the instructions on the right half of the screen. So we'll go here. This is the Toolbox app. We can download versions for various operating systems. We're on Linux. We're going to use kdesrc-build in order to program for KDE. So that means that we will need to use the Linux operating system. The option that we're given in here is to download a archive with extension tar.gz. So let's do that. We're going to use the downloads directory. Okay, so let's read. So says download the tar.gz. We did that. We will download the file into /downloads, which we did. So let's have run the instructions in a terminal console. Let's see if the instructions are correct. So the version is 213.18.901. Okay, so it's the same version. We probably can just run this command line. Okay, and now we have an executable in my home directory, the .opt directory, JetBrains Toolbox. Let's see how that looks like. Just one executable. Okay, let's run this thing. It's a graphical user interface application. We're waiting for it to actually install itself. And now we're at the first run wizard, where it says welcome to the Toolbox app in here. Continue. We need to accept the EULA. Let's go with dark this time. Get started. And here are all of the applications from JetBrains that we can install. We'll not install CLion Nova. This is a preview. Integrated development environment for C++. We will go with the CLion. So go install. We can see the progress. So this application JetBrains Toolbox has been actually installed by this installer. So this is just the installer. This is the installed application JetBrains Toolbox. And if we look in the KDE Plasma Desktop Start menu for Toolbox, here it is, JetBrains Toolbox. Let's see where it installed itself. So into my home directory, tilde/local/share/jetbrains/toolbox/bin/jetbrains minus toolbox. So tilde/local/share is for no arch files, so not for executables. For executables, it's tilde/bin or tilde/.local/bin. But that's the way JetBrains does it. That's how they actually test the product. That's how the product is meant to be installed. It installed itself in the place that it wanted to be installed. And then we're going to use JetBrains Toolbox, the same, for making sure that the IDE CLion is installed as JetBrains, the company, wants it to be installed. So in my home directory, in the same place, tilde/.local/share, etc. Okay, so I could install CLion by just downloading the, let's see, for C++ CLion. So I could just download the targz for CLion, but then I would maybe choose to install it in tilde/.opt or in /opt. Whereas by using the JetBrains Toolbox, the IDE will be installed where the software vendor intended, and maybe even more in a more correct and in a more easier to support form. And apart from that, we have an entire list of integrated development environments that we can choose from, even the gratis ones, which can also help while programming for KDE, such as the integrated development environment for Python, which is PyCharm community. Okay, so CLion is now installed correctly. Let's go back to my page and see what's there. From the start menu, we have now access to the integrated development environment, which is called CLion. This one, CLion, and with a subtitle, a cross-platform C and C++ integrated development environment. In the correct category, in the KDE Plasma start menu, which is the category development. Okay, so let's start CLion. We can close the JetBrains Toolbox. We will not need it for a while. Also, by using JetBrains Toolbox, you have an easy graphical user interface way of upgrading your IDEs once a new version is released. So gears and then quit. Okay. So previously, in my previous instructions, I just downloaded the CLion targz file and used that, but now I've switched to using the Toolbox app and let the Toolbox app install CLion, update CLion, do what's needed. Okay, so CLion has started. At first run, it shows the import CLion settings dialog. Do not import anything is the correct setting. Okay. Splash screen. If we want to help with optional metrics. Okay. What else? Start trial. This thing. Okay, so we have a 30-day trial. We don't need to create an online account. It's just per computer. Okay. What else? Let's look at the application launcher that's in the start menu. Right click on it, edit application, and it's in the same directory, tilde/.local/share/JetBrains. And then the toolbox handles its own applications. Okay. We're at this step where we finished installing the CLion C++ integrated development environment. Next up, we'll need to set up kdesrc-build and build some projects. Let's go there. Get involved, set up development environment. We're on Fedora, so let's run this. Let's have a new tab, Ctrl-Shift-D, Ctrl-Shift-V. Okay, this is okay. Let's install. Okay, next up, we're not going to write to the KDE Git repositories, we're going to read from them, so no need to configure the Git user. Okay, now we're going to git clone the KDE Git repository from this GitLab project, so https://invent.kde.org/sdk/kdesrc-build. Where am I? Okay, so I did not copy the last character, this one, the D. Ctrl-Shift-V. Okay. Next up, this section is special for the Debian family of operating systems or for the OpenSUSE family of Linux operating systems. So let's skip over it. Next up, it's these. Okay, so it installs many binary packages from my Linux operating system. I'm on the latest version of Fedora KDE Plasma Desktop Spin of Fedora. So it installs RPM files from the Fedora repositories, many libraries that are required by the KDE Frameworks version 5, by KDE Frameworks version 6, including most of the Qt 5 and Qt 6 packages, RPM files. Windowing libraries, image libraries, audio video codec libraries, compression libraries. This will make it simpler for us to build individual KDE Git repositories, because most KDE Git repositories will not build until you install from your Linux operating system a large list of binary packages. So in my case, RPM files from Fedora. Okay, 711 RPM files to download and install. I will pause it for a second until it finishes installing. The RPM package is finished downloading, and now we are installing kdesrc-build. The configuration file has been created in this file, so tilde/.config/kdsrc-build-rc. I do not want to change any configurations in my command line shell, so I'm going to press N or Enter for no. Don't edit the .bashrc file. I'm not losing much. Next up, I'm going to move this file to the current directory. This makes the current installation of kdesrc-build portable, and that's the way I do it. So I'm going to do it here, even if we don't really need to have the installation portable. Okay, let's look at the configuration file. I'll keep the defaults. We're at this step. So we're going to keep the defaults, but since I'm going to use CLion for debugging, I want the CMake build configuration to be debug, not rel with debinfo. I want way more cores when building. I have 14 vCPUs, so let's go with 12 threads, not cores. And I can also replace this with nothing. It's a placebo, doesn't do anything. Ctrl S. So that's it. I'm keeping the defaults. I've just edited this to use more CPU threads than 4. And I'm not using rel with debinfo, but debug as the CMake build configuration. Let's start building. I don't have kdesrc-build executable in my path environment variable, so I have to always go to this directory, tilde/kd. So let's show /kd/src/kdsrc-build. And in here I need to prepend my kdesrc-build commands, command lines, and kdsrc-run command lines with /. Okay, the very first thing that I always build is kconfig. So it git clones one KDE Git repository, the second, which is going to be built, and the third KDE Git repository is being cloned and built and installed. Let's look at the file system structure a bit. How do we do that? I'm not a user of Dolphin. This thing. Okay, and a new tab. Ctrl T. Ctrl T works great. How do we hide the sidebar? So in the KDE directory, in my home directory, there's 3 subdirectories. In the src subdirectory, KDE Git repositories have been cloned, and that's it. So this is just a clean Git clone of the kdesrc-build Git repository, a clean Git clone of the keyconfig, KDE Git repository, etc. This is for building, build artifacts, CMake, generated files, Ninja, etc., which are then copied. So the build artifacts, which come from this directory. So lib kf6 config core.so 8.3 megabytes is then copied to the destination directory, which is tilde/kd/usr/lib64 in this case in here, 8.3 megabytes. This is the step called installing, which takes files from tilde/kd/build and puts them into tilde/kd/usr. kdesrc-build works correctly. We have built this KDE Git repository. The example then builds kcalc, which let's also do. Again, prepend everything with /. So this will git clone 23 Git repositories. 3 were already built and git cloned and installed. So there's 19 to go. I'll be back once kdesrc-build finishes building the KDE Git repository kcalc and all of its other KDE Git repository dependencies. Kcalc was built successfully using kdesrc-build. Let's actually make sure that it was built correctly by running it. Okay, it runs correctly. The looks could be improved by using kdesrc-build in order to build the KDE Git repository plasma minus integration. We're not going to do this time. So now we're going to look at how kdesrc-build runs the cmake configure command line. For that, kdesrc-build first sets some environment variables, changes into a certain directory, and then runs a long cmake command line. So we need all three of those: directory name, list of environment variables, cmake long command line. Yes, we need to prepend everything with /. Okay, and we're going to stop by using Ctrl+C after the cmake configure step starts, or when it starts building, you decide. So if the build has started, I stopped the kdesrc-build command line by using Ctrl+C. The entire output from the cmake configure step can be seen here. We can see that it was successful. And let's look at this block in here. So ending in here and starting in here, as it says, running cmake targeting kdenninja, cd into one directory, run logged command, setting some environment variables, command line, and then directory. So this entire block, we'll need to copy it. Let's use Kate. Ctrl+V. Okay. We need to open this file, so the cmake lists.txt file from the directory where kdesrc-build has git clone the KDE Git repository kcalc. So let's find that directory. So ~/KDE src kcalc, and this is the file. How do we copy the path? Copy location, Ctrl+Alt+C. Great. So this is the first time when you start CLion, or when you close all projects and then restart CLion. It asks for a project that I want to open. So I go open, and then I'm going to paste in here the full path. I go OK, and it asks me if this is a cmake project and I want to open it as a project. Yes, I do. Okay. Enable checkbox trust, and then trust project button. Okay. Let's see next. We can either go where it says in here, so in the CLion main menu, file settings, build execution and deployment, cmake, and then select the profile debug. Or in this case, because no project was opened and I'm opening a project, it automatically went there. We're in the exact same place, in the place where we can configure CMake, this dialog. If this dialog is not automatically shown when you open a project, then these are the steps that you need to perform. So CMake, CLion main menu, file settings, build, execution, deployment, CMake, and then debug. But we're in this directory already. So let's look at the build directory. Where are you? Where am I, actually? So CMake profile named debug. Keep wizard use defaults. Okay, now we're in that page. So I press the next button. So in toolchain CMake, debug CMake build configuration. We first populate this edit box, so the build directory. And we take data from the Kate text editor. So it says that we should change into this directory. I'm copying the directory as is in here. Then, so this is this step. Then we want the CMake command line, which is at the end, for instance, this part. Let's remove the single quotes. So this is an array of command line arguments. We want to convert this thing into a valid command line that we can run from our command line shell. So for instance, from bash. So for that, we're going to replace all of these things with nothing. And since this is just one command line argument, kate space minus space ninja, and contains spaces, we're going to wrap it in double quotes. The other possibility is to not use double quotes, but escape all of the spaces with backslash. Okay. So says look at the command line, which I did, and ignore just two of the parameters, so minus b and minus s. The rest of the CMake command line, which is this thing, I need to paste into CMake options, which is this thing, Control V. Now it automatically determined that the generator to use is custom Kate Ninja. And what we're missing now is just the environment variables. So we need this block with setting environment variable, which starts here at line 5, ends at line 11. Control C, new, Control V. And then let's do the replacements that it says I should do, which is this thing, Control R, replace all, so this thing. And then I need equal signs. Control R equals replace all. Okay. I computed a block of text, which I should make available for my future me. And I'm going to use it right now. So in the environment text box, I have edit environment variables, shift enter, click on it, and then the paste icon. The environment variables were populated correctly in this graphical user interface with pairs of name and value. Press OK. And that's it. Nothing else to configure. Finish. Okay, let's see if the output from CMake is identical in here with the one that we had in generated by kdesrc-build. So it starts with CMake deprecation warning, which is the same output. Then this warning, following optionals have been found. Listing following optional have been found, following required have been found. So it's successful and the output is identical. And even says build files have been written to. This is all that we actually need to configure inside of CLion. If the CMake configure step is successful and identical to the one that's run by kdesrc-build, then we're good to use to use the integrated development environment CLion. Okay. Let's do these steps to make extra sure to prove to ourselves that we've configured CLion correctly. This is totally not needed, but we're going to go the extra mile to prove that we're not using remnants from kdesrc-build. We're doing everything inside CLion. Okay, so this is in CLion, the CMake tool window, this thing. It says I should press clear all, which is the recycle bin icon. Then I'm going to press reload CMake project, this button. It should show the same output, which it does. Then CLion main menu build. So this is the main menu hidden. Build and rebuild kcalc. Okay, 32 translation units. And finish successfully. Let's make sure that we can run. So this was building the KDE Git repository correctly using CLion. Now we'll need to learn how to run and how to debug. So for run, main menu, run, edit configurations. In the middle of the menu, we can choose a CMake target for an executable. We have kcalc in here. And it says that in environment variables edit box in here, I need to do the same thing that I did previously, which is paste this block. Click the paste button. OK. And OK again. Let's now run the thing. So CLion main menu run and then run kcalc, which is Shift F10. Kcalc starts correctly. Let's close the application. It was enough for us. Next up, we want to debug kcalc. So for that, we'll put a breakpoint into the entry point, which is, this is a C++ project, so the main function. We can go there by choosing the file kcalc.cpp in the top level. Then we can use the structure tool window, collapse kcalculator class, and go main. Let's close this thing. Put a breakpoint in main. or we can just click on this button. Okay. When we click on this button, it asks if I want to debug. If I click on this button, it will start the debugger. I can also start the debugger from the main menu or run and then debug kcalc shift F9. Okay, the debugger has stopped correctly on line 2802. I can inspect the local variables, etc. I can, how do I do stepping into? Step into F7, 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 etc. Let's look at the call stack. This thing, so we're in main, the first place in the core stack where we have control and the source code. So we can put a breakpoint in here. The other functions above it are from glibc or from libc, from glib, etc. Okay. So in here, we're inside the constructor of qByte array and inside the constructor of qArray data pointer. Let's go back to this level. Step out twice. Okay. Step into again. And now we're in the method set application domain in klocalized string, which is called here. So the debugger works correctly. As an extra precaution measure, we can do these steps. So let's actually do them. So in the debugger tool window, debug Alt-5, there's a tab which is called GDB. GDB is the GNU debugger. And CLion is using that, is instrumenting the GDB debugger. Let's go info proc. We can run GDB commands in here. It says that process ID PID is 35259. Let's paste it here. Okay, and then we're going to edit this command line. Control C. We have a terminal already open. We can run the command here. And we want to make sure that the environment variables of the running process, which is run by the CLion debugger, which is run by GDB, which the process is named kcalc, has the correct environment variables set. So the environment variables should be Qt plugin path, this thing, and it's set correctly. Should have this path. Unfortunately, the environment variables are not sorted alphabetically. How can we fix that? Just a second. Of course, it's the sort Unix command, but autocompletion did not work. So, okay, so I searched Unix sort alphabetically, and it says use the sort command. Okay. So now the environment variables in the side of the process kcalc are these and sorted alphabetically. Let's look at the path environment variable. Starts with tilde/kd/usr/bin, and then the previous, the path environment variable that's for the rest of the processes for my user. Okay. So kcalc has been started correctly using the correct environment variables, and we're inside the debugger, we can do all of the things that we can do inside debugger, such as inspecting variables, looking at threads, and at, so this is the list of threads. At call stacks, we can put breakpoints, step into, step out, etc. Okay? And the output from standard output, standard error from the process. Okay, let's show some things that we can do using CLion. Let's stop the debugger. So I have a list of merge requests that you can propose to KDE Git repositories that don't take that much time if you are a C++ programmer. So depending on your C++ knowledge, doing a merge request of as suggested in this wiki page might take might take only 30 minutes. So let's see an example with CLion. We can do proofreading using CLion. So I opened a Git repository in CLion, and then there's the analyze the entire project, which can be found, for instance, in here in the problems tool view. And we go project errors, inspect code, whole project, and analyze. Okay. We're going to fix grammar issues if we find such a thing. So typos, I didn't have that much success looking at this category of issues, typos, because most of the time the issues are with names of people or with the names of projects. So it says that kcalc is misspelled because it doesn't exist in any dictionary, and then it offers you to add kcalc to the dictionary. But then in order to fix some of to have less typo issues, you're going to add many words to the dictionary. When you open in CLion another KDE Git repository, there will be thousands of typo issues which will require you to add more strings to the dictionary, etc., etc. So this is an example. The name of a person, Tehran, is not a valid English word. So let's ignore typo, but then not ignore grammar. Okay. So says that in English US, afterward is better than afterwards. Need to copy data list because sorting afterwards. So it's this doesn't sound like valid English because we are sorting after something. So we could rearrange this part of the comment. Long is not a repeated word. That's an actual type in C++ unsigned long. Not a proofreading error. Non-breaking space. Okay, we should put probably a minus between non and breaking, but we're going to ignore this thing for now. A and B. So this is not actually opening a parenthesis. It's having bullet points. Okay, neither applies to binary, hexadecimal, nor octal. Yeah, why not? Okay, for now I'm ignoring this type of errors where a comma may be missing, a comma. Okay, next. So I'm not looking at missing commas. This only updates the core to bring the changes to the display. Use afterwards. Not sure. Meta object. Okay, so that's all. The KCalc project is one of the better maintained KDE Git repositories, so it has way less issues. Some of the KDE Git repositories at the periphery of the KDE projects, such as KDE Games, KDE Utils, the projects that have still not been ported from Qt 5 to Qt 6 completely. Those might have more issues found by the static analyzer in CLion. This unused code, I didn't have any success with them yet. So unused code means that you have a method that's private and not called from the function, but then from the class. But then if you have like this public methods, maybe this is exposed outside of the DLL or something. So you'll need to be mega careful when you try to remove a public method that some static analyzers suggest that it's unused code. Okay, this is most of the issues found by clang tie. They are of this type. Function should be marked no discard. I have seen the C++ source code of the Qt 6 frameworks, and they're full of no discard. So maybe that's what we need to do in the KDE Git repositories, to add a bunch of no discard before the methods. Or you can choose to ignore this issue. Static member accessed through instance. This is very valid. This is easy to act on, should be done. So in here, instead of saying this dot something, you should say class name : the name of the static method. And the same here and here. So these are valid and should be done. Okay, we can copy the error by going Ctrl+C. Okay, and then let's look at another type of issue that we can fix, is deprecation issues. For instance, in the Qt source code, there are C++ defines, so macros, which remove some methods from the Qt source code, or trigger build warnings, etc. if these defines are whatever, defined or not defined, or their value. Okay, so let's try to see how the KDE Git repository KCalc handles this define Qt no cast from ASCII. How do we search? Okay, so let's edit the configuration file. Where did we do that? Let's actually find it interactively in here. So in the ~kdesrc directory, we git clone kdesrc-build, and the configuration file is called kdesrc-buildrc. This file, let's open it with Kate. And as the wiki page says, we should replace the line cmake options dcmake build type debug, or we should append to this line. Let's go just this. Okay. And then we'll see if the KDE Git repository kcalc actually undoes my define using such blocks in the cmake lists.txt file, or using some other trick to undefine this C++ macro. Fine. Okay. So we're going kdesrc-build, kcalc, no src, no include dependencies, refresh build debug. So we want the deepest and cleanest rebuild possible, but only of this Git repository. Let's look at the command line of cmake. So it has defined it here, Qt, no cast from sg equals on. And there are no errors. So some of the KDE developers have fixed all of the issues related to the deprecated functionality in the Qt framework's QString and related conversions, string conversions. Okay, but this is a way of identifying build warnings or build errors and fixing them. I can show you an example of such a merge request that I have proposed. So because the Dolphin, which is the KDE file manager, has way more source code and more complicated than source code than the KDE desktop calculator, which is kcalc, I could find such issues by defining these two defines, and I have fixed some of them. 10. So a small number, then did one git commit and one GitLab merge request. So you shouldn't create a merge request that contains 100 lines changed. So propose some that are small. If you're going to propose just one, when there's 100 warnings of the exact same type in the same KDE Git repository, and you're going to do just fix one of the warnings, do a git commit, a merge request, that's going to result in 100 merge requests, and that's going to be too many. So keep a middle ground between doing too much inside of a merge request and doing way too little. If you're doing too much in a merge request, the merge request will probably never get accepted. There will be all sorts of issues that you will need to fix, like this. Okay. So what this change says is that in Qt 6 you should not pass a const char pointer, so the native const string type in C++, where you need to pass a Q string. You should always convert that thing. In my case, it's 7-bit strings or characters to QLatin1 char or QLatin1 string. And also, instead of concatenating like this, maybe you want to actually format a string using .arg as an example. So instead of concats, you're going to use the method .arg of QString, the basic canonical string type from the Qt framework. Okay, and these were this is a QString, whereas this was a buffer byte from Qt. So you should know what's the actual encoding of that byte of buffer that contains a string. Maybe it's UTF-8, maybe it's Windows MBCS, maybe it's Windows UCS to UTF-16 little endian. You should know what's in your byte buffer and then use the correct method to convert to a QString. So it might be QString from UTF-8, QString from Latin1, etc. So this is it. I have a fresh Linux operating system, which is Fedora KDE Plasma Desktop Spin. In here, I have installed the application JetBrains Toolbox. From the application, I have installed JetBrains CLion, and now the application is going to be able to update CLion. And we're using the 30-day evaluation inside of CLion to program for the KDE community. So use all of the features that the CLion integrated development environment has, such as build, syntax highlighting, go to definition, debugger, etc. And if you have the money, you can buy a license, or maybe you're still in university and you have a free license available for CLion. And then on top of this, we can build even further because we can use CLion to do static analysis of huge KDE Git repositories. It's going to find tens of thousands of issues. Not all of them are as actionable, but then you have plenty of chances to create a KDE merge request. Declaration shadows a local variable. How is that possible? So you need to look at the individual warnings and study them very deeply. So invest, I don't know, at least 20 minutes to really find out what's happening inside of that warning. And once you're confident, you can start doing merge requests. And if the issue appears tens of thousands of times in the 400 KDE Git repositories that can be built using kdesrc-build, then you have chances to do hundreds of merge requests across different KDE Git repositories. Once you understand a warning really deeply and you see that merge requests fixing this issue are being merged by the KDE community. Thank you.